Hey there. Ever wished you had like a clearer way to understand just how big an effect is in your data? Instead of only seeing if it's statistically significant. Well, get ready, because today we're doing a deep dive into a new effect size measure you might have heard of called Phi.
Sounds intriguing.
It is. We're taking a look at this really interesting research article. It's got a kind of catchy title, actually. Faux thumb. Effect sizes for categorical data that use the chi-squared statistic.
Catchy. Gets you thinking about fairy tales and giants and then stats.
Exactly. But don't worry, no giants here, just good stuff. Now, you're probably already using p-values in your work, right?
Yeah.
But let's be real for a sec. Sometimes p-values, well, they kind of leave us wanting more.
Totally. It's like, yeah, knowing something is statistically significant, that's great. It's definitely a good starting point. But it doesn't give you the full picture, does it?
Right.
It's like seeing a little blip on a radar screen. Something's there. But is it a tiny fishing boat or a gigantic cargo ship? That's what effect sizes give us, that crucial context. They reveal the magnitude of the effect, how big of a deal it really is.
So true.
Yeah.
And this is becoming even more important now with everyone focused on making research more, rock solid, more reliable.
Yeah.
I bet you've heard of the replication crisis, where findings from some studies based only on p-values, haven't always held up when other researchers try to replicate them.
Exactly. And that's where these effect sizes, they become really essential. They're absolutely crucial for building a solid body of knowledge and for those big meta-analyses everyone's talking about, where researchers take data from lots of different studies and combine it.
Right, to get the big picture.
Yeah, the big picture. But to compare all those studies properly, we need a standardized way to measure how big those effects actually are, and that's where Phi and all its companions, that's where they come in.
Okay, so let's say we're looking at something like, I don't know, how about coffee preference? And whether someone's a morning person or not.
Ooh, good one. Relatable.
Yeah. So we're talking categories here, right?
Yeah.
Like coffee lover or tea drinker, morning lark or night owl.
Categorical data, exactly. Always fun.
Right. And we can put all that data, visualize it nicely in what's called the contingency table, which is like, imagine a spreadsheet, basically, that shows how many people fit into each combo.
Right, like how many are coffee-loving morning larks, how many are tea-drinking night owls, and so on. Each combo gets its own little box.
Exactly. And to figure out if there's a real connection there, not just random chance, we use this thing called the chi-square test for independence.
Yes, the chi-square test. It's a classic. It basically tells us, hey, is there something interesting going on here? Or is it just all random noise?
Right. Is there a relationship between those categories or not?
Exactly. And here's the thing. Even if that chi-square test tells us, yeah, there's something going on, it doesn't tell us how big of a deal it is,
It's like that radar blip again, right?
Exactly. We need to know, is it a canoe or a cruise ship? And that's where effect sizes step in to save the day. They give us that aha moment, that, oh, now I get it feeling, by revealing how strong that connection actually is.
So it's not just, yep, there's a link. It's like, whoa, this link is huge EE, or, well, this is kind of subtle.
Precisely. And for a simple 2x2 table, like our coffee and morningness example, one common effect size measure is Phi. Phi, yeah, written with the Greek letter. And the great thing about Phi is it acts a lot like a correlation coefficient, that familiar 0 to 1 range.
Oh, okay. So like closer to 0 means there's not much going on, but closer to 1 means there's a strong relationship.
You got it. So if we calculate Phi and get, say, 0.8, bam, we know there's a pretty strong link between loving coffee and being a morning person. That gives us way more info than just knowing it's, quote-unquote, statistically significant.
Right, way more useful. But I'm thinking real life's usually more complicated than just two categories, right? Like, what about people who are decaf only? Or how MCH coffee someone drinks?
You're thinking like a researcher now. And you're right, things get more complex. But don't worry, we've got an effect size for that. It's called Kramer's V.
Kramer's V.
Yep. It's like Philemma's more sophisticated cousin. It can handle those bigger, more complex tables with more categories. But the best part is it still gives us that nice, easy to understand 0 to 1 range so we can compare apples to apples.
Oh, that's so helpful to have that consistent scale.
Right. Makes it so much easier to compare results from different studies, which is super important for those meta-analyses we were talking about.
Makes sense. But, okay, what about when we're not looking for connections between categories, but instead we want to see how well our data fits a specific pattern, a specific distribution?
Great question. That's where goodness of fit tests come in. Imagine it's like trying to fit puzzle pieces into those designated spots.
Oh, I like that.
Do they all line up perfectly, or are there some gaps, some mismatches?
So with a goodness of fit test, we're seeing how well our data fits the pattern we expect to see.
Exactly. And for this kind of test, one effect size measure people have used a lot is Cohen's W.
Cohen's W.
Yes. But just like some puzzle pieces, Cohen's W, well, it doesn't always fit perfectly in every situation.
I see where you're going with this. There's got to be a but coming.
There is. Cohen's W, it can be a little, shall we say, particular when the data is spread out unevenly or there are more than 2 categories. Things can get a little messy.
All right, so Cohen's W, it's got a few quirks, especially with certain data situations. Which brings us to, drumroll please, Faye.
Ta-da. The star of the show. And yeah, Faye, it's like that puzzle piece that just fits, where others couldn't quite cut it.
Okay, tell me more. What makes it so special?
So unlike Cohen's W, which can be a bit finicky, Faye's reliable. No matter how many categories you've got or how spread out the data is, Faye handles it like a champ. It's like having this, I don't know, like a universal measuring tape that works for anything.
I like that. No more forcing square pegs into round holes, right? Faye brings that, what is it, elegance? Flexibility?
Both. It's elegant and flexible. But here's the really cool part. It's not just about describing what's already there in the data.
Okay.
Faye can actually help us shape future research, too.
Whoa, hold on. Back up a sec. How does it do that?
Because Faye is, deeply connected to that chi-square statistic we talked about earlier. It gives us this amazing ability to do more accurate power calculations.
Power calculations, right. Remind me again what those are all about.
Of course. Basically, power calculations, they help us figure out how big our sample size needs to be to actually detect a real effect, if it's there.
Right. So we don't end up doing a whole study and then realize, oops, we didn't have enough people.
Exactly. It's like choosing the right zoom level on a camera,
Right.
Too far out and you miss all the important details, too close and you lose sight of the bigger picture.
Faye's like our zoom lens for research.
I like that. So by knowing what kind of Faye we're aiming for, we can calculate that sweet spot for our sample size. No more guesswork, no more relying on those old rules of thumb. We can design studies that are both super rigorous A&D efficient.
That is so practical.
Yeah.
So, Faye, it's not just about interpreting the data. It's a tool to help researchers do better research.
Exactly. And the more researchers dig into Faye, the more we're going to discover even more ways to use it. Even more nuanced applications and insights. It's exciting.
It really is. So to bring it all home, we've gone from p-values and their limitations to Faye with its simplicity, Kramer's V and its adaptability, and now Faye with all its potential.
And what's even more amazing is that now you, listening, you're equipped with the knowledge to understand and even use these effect size measures in your own work.
We've taken these kind of mysterious statistical concepts and hopefully made them a little less mysterious, a little more usable. Remember, effect sizes, they're not just numbers. They're stories waiting to be told. They give us that crucial context to make good decisions, whether we're reading a research article or designing our own study.
Couldn't have said it better myself. And hey, who knows? Maybe one of you listening will be the one to uncover some brand new, super innovative way to use Faye, push the boundaries of what we know.
Love it. All right, until next time, everyone, keep exploring, keep asking those good questions, and keep that statistical curiosity alive.